You ever wondered why most of the major mountain ranges are parallel to the mid-oceanic ridges? You ever wondered how the mid-oceanic ridge got there? It's a 46,000 mile mountain range that was made. Look at the cracks. They're straight. Those are tension cracks. That's not compression cracks. Tension is when you're pulling on something and then it'll crack and then it releases the pressure. So this has tension cracks in two directions. So how do you make a mountain by stretching it in two directions? That doesn't make sense. And they had this startling discovery. The Earth's crust is missing in the Atlantic. Why is that? And so now you got all this stuff crumbling into that flow. These two cliffs are getting wider and wider apart. And pretty soon there's nothing pushing down on that mantle. And so the mantle bulges. That's how you get the mid-oceanic ridge. It bulges, stretching it in two directions. And so now it's like lifting up a train track. The train's going to start rolling. So that's what happened. The continents start sliding, and so there's even less weight on the mantle, and so that it bulges even more, and there's less, and it bulges even more. So you got North America and South America going to the west, and South and Africa and Europe going to the east, and they keep going until they meet resistance. And that's why their missing crust is in the mid-Atlantic. It either eroded away or it slid away. That's startling, they say. And that's why, they keep going until they meet resistance, and then they buckle up. Like if a rug going into a carpet, a wall or something's going to buckle, or a car accident, the hood buckles. That's what happened to the plates. They buckled, and that's why the mountains are mainly parallel to the mid-oceanic ridges. And this over here, the Andes are half as big as the Rockies. And I think that's because the plate slid over the mid-oceanic ridge. And when it slid together, there's a lot of force, there's a lot of heat, there's a lot of pressure. And that's where we get our coal and our oil and our metamorphic rocks like marble and diamond. And those things still have carbon-14 in them. So they're not millions of years old. They find carbon-14 in everything that they shouldn't find it in based on that evolutionary theory. And this is, I think, in British Columbia. These are mountains that had to be soft, pliable mud when it was pushed together because there's no cracks there. They got pushed together. And you can do an experiment at home. Take your finest china and bend it. See what happens. See if it'll crack or see if it'll bend. And these are compression cracks. We had talked about tension cracks, which are straight. These are compression. This is Gunnison Canyon in Colorado. They got crushed together, and as the rock's crushing, the quartz in it melts and fills up those little lines. And it's really hard to do. Okay, and you get the same type of rock, these quartz-filled cracks in crystalline rock, the same things at the inner gorge. Something crushed. I mean, a lot of force was used. And so that's how we get the mid-oceanic ridge stretched in two directions.